Today's lesson we're going to be talking about direct inverse and joint variation. We're going to talk a little bit about direct variation first. Basically, we're going to be dealing with a constant, A, and its relationships between x and y. X and y have a direct variation. Y is going to be equal to a times x. Looks a lot like the slope of a line, which it actually is. Some real life examples: the more money you make, the more taxes you pay, that sort of thing. The more money you make, the more you should be able to save. So, something that increases, it's something else increases. These problems, you can solve with a proportion, but we're not, because what I want you to do is actually focus on finding the constant. So I want you to focus on this. The variable y varies directly as x. So that means y equals the constant times x. And y equals 9 when x equals 3. So the first thing we want to do is find a. So we're going to substitute what we know. And so a is equal to 3. And write an equation that relates x and y means you're going to substitute the constant back in. So your answer is two parts. You're first writing the equation right here. And the second part, you're actually going to use it to predict something. So then find y when x equals 14. And we'll substitute 14 in. So 42. So two different answers. Okay, now what we have here is an example of direct variation, and it's relating the length of a shark's body with the length of its tooth, or teeth, as the misspelling has here. If the length of a shark is 290 and its tooth length is 2.4, write an equation relating the body length. So that means we're going to have to find the constant. So it says the body is directly proportional, so the constant times the length of the tooth. So we need to find the value for a by substituting in. So we've got 290 equals a times 2.4. A is going to be equal about to 120.8. And so to get our equation, we have the body of the shark is equal to 120.8 times the length of the side of the tooth. Then we're going to find the approximate length of a shark that has a tooth length. So what that means is we're going to substitute in the tooth length for t. And so the approximate length of our shark is going to be 700.6 centimeters. And for these types of problems, good idea to round to a tenth. Now, inverse variation is the opposite of direct. Direct means something that's larger. The result is a larger result. Inverse means as something is larger, your result's going to be smaller. So the relationship between your variable and your constant's the same, but you're going to be dividing by the other variable. So remember, a is constant. So when you see the word inverse, you're going to divide by the other variable. So, two-part question again. Write an equation that relates x and y. So y is equal to a over x, which means we need to find our value for a. So y is 15, x is 1/3. So you're going to multiply 1/3 on both sides to solve for a, so a is equal to 5. So your equation is y is equal to 5 over x. That's the first part of your answer. And then it says find y when x equals negative 10. So y is equal to 5. Divide by negative 10. So y is negative 1/2. Okay, now joint variation makes it sound like that it is a mixture of direct and inverse, but it's really not. Joint variation is multiple direct. Okay, so you'll be dividing multiple variables, or multiplying multiple variables by your constant. So example 4, the variable z varies jointly, so multiple direct with x and y. Also, I've given you 3 starting places. I've given you a value for z, x, and y, so that we can find a. That's the first thing you have to do, is find a. So our model is z is equal to a times xy. So we're going to substitute in. So that gives us negative 20 equals to x times y. And we'll divide both sides, so we'll get negative 3 is a. So your model, z is equal to negative 3 xy. Okay, now it says find z when x equals y, x equals 7 and y equals 2. So we get negative 3 times 7 times 2. And that means z is negative 42. Now this slide is just practice for writing models, writing equations for these relationships. R varies inversely. You're always going to start with writing the first variable equals with your constant and either multiplying or dividing. The inversely is an opposite relationship, so you're going to divide. Same thing. Z equals your constant, that's always going to be the case, and it's jointly, which means you're going to multiply, but you're multiplying x and the square root of y. You need to have the square root. So x square root y. Q varies inversely. That's a division. So here's your constant, cube of p. And then the last one, you're doing a combination jointly with u and v. That divides, that multiplies inversely, means you're going to divide. So your first variable and your constant. Jointly, u times v, inversely square of w. And this is just a little practice for solving the problems. Last slide, little physics for us. Boyle's law states that for a constant temperature, the pressure P of a gas varies inversely. It means we're going to divide it into our constant with its volume V. A sample of oxygen gas has a volume of 50.25 cubic millimeters at a pressure of 20.6 atmospheres. So we're going to find the constant. That means find A. So inverse means we're going to have pressure equals A divided by volume. And we're going to solve and plug in 20.6 equals A divided by 50.25. Change that, my period's in the wrong place. So A is the constant, and it is 1035.15. No units with your constant. We're going to write an equation that relates P and V, so we're just going to substitute in for the A. But you can rewrite this, because my next equation says find volume, so it's really more useful for me to be in terms of P instead of in terms of V. So I'm going to multiply both sides by volume and then divide both sides by the pressure. And that equation relates P and V. It shows that they have an inverse relationship. Now we're going to use this to answer a question. Find the volume of the oxygen gas if the pressure changes to 15.2 atmospheres. So we are just going to substitute in. And because this problem asks for units, we are going to give it units. And this is going to be an approximate when you divide 68.1, and the units for volume is milliliters cubed. So little m, big L, and a cube.